A lending team needs to change one number. The maximum loan to value in one state moves from 75% down to 70%. Finding the number takes about a minute. Getting it into production takes 6 weeks. The number lives in the middle of a 200-line method inside an OH assembly that 11 other services reference. So changing it means a full build, a regression pass, a release window, and a rollback plan. The gap between a 1-minute change and a 6-week deployment is what this video is about. We are going to build a rule engine in C#. Business rules become ordinary classes behind one interface. An engine runs them in order and records exactly what it did. Rules arrive from a policy file and from assemblies dropped into a folder while the service is running. Everything shown here compiles and the tests run at the end. This is the method we are replacing. It is a real shape, not a strawman. Every branch in it was added by somebody solving a genuine problem on a genuine deadline. The first 3 checks are the ones you would write on day 1. Credit score below 620, decline. 2 prior defaults, decline. Debt to income over 43%, decline. Then comes the employment block, and this is where it starts to go wrong. A self-employed applicant needs 24 months of trading history. A contractor needs 12. Everybody else needs 6. The self-employed debt to income ceiling is 38% rather than 43%, and the comment beside it says the number came out of a bad year in 2023. Nobody remembers why it is 38. Underneath that is the regional block. Karnataka caps loan to value at 75%, Maharashtra at 80%, everywhere else at 85%. Every new market a lender enters adds another branch here. This method is the reason a lending launch needs an engineering release. Read the whole thing and then ask what it can tell you. It returns one word. It cannot tell you which checks ran or why a borderline application was referred instead of declined. Reordering 2 of these branches changes the answer and nothing warns you. 4 costs and only one of them is readability. The first is deployment. A policy number and the code that uses it sit in the same binary, so changing the number means shipping the binary. The second is evidence. A lender that declines an application has to be able to say why, and a method that returns one word cannot. Assembling the reason afterwards from a second pass over the same data is exactly the practice regulators object to. The third is testing. A case that exercises one branch near the bottom has to construct an application that survives everything above it. So those tests get long and then they get skipped. The fourth is order. Every early return in that method is a decision that the checks below it do not matter, and none of those decisions were written down anywhere. We will find one of them later that nobody intended. The first thing to build is the contract, not the engine and not the rules. The interface that everything else agrees on, which turns out to be 4 members long. Getting it this small is most of the work because every member added here is a member that every rule has to implement forever. Start with what a rule returns. Not a Boolean, because the interesting cases in lending are neither yes nor no. 3 outcomes instead. Pass means this rule has no objection, and it deliberately does not mean the application is approved. Refer means send it to a human. Decline is a hard stop that no later rule can overturn. Alongside the decision sits the reason, and the reason is not decoration. A lender that declines has to state why in a sentence a person can act on. Making it part of the return type means a rule cannot produce a decision without also producing an explanation for it. That is the kind of constraint worth spending a type on. The verdict is a read-only record struct. It is small, it is copied rather than allocated, and one of these is created for every rule on every evaluation, so the choice is worth making deliberately rather than by habit. Here is the whole contract, 4 members. Code is a stable identifier that goes into the audit trail. It is a string rather than the class name on purpose because a class gets renamed during a refactor and 5 years of decision records should not be orphaned by a rename. Priority decides the order, lower first, and it has a default implementation. Cheap decisive rules belong at the front, so an obvious decline never pays for the expensive checks behind it. Applies to answers whether this rule has anything to say about this application at all, and it defaults to true. Those 2 defaults matter more than they look. A simple rule is now one property and one method, and region-specific rules opt themselves in rather than the engine hardcoding who applies to what. Then evaluate which does the work. The type parameter is marked in, which makes it contravariant. A rule written against a broader context is usable by an engine built for a narrower one. In practice, that is what lets a shared policy library ship rules every product team can consume without recompiling anything. The engine returns a decision and the complete record of how it reached it. Every rule appears in the trail with one of 4 statuses. Evaluated means it ran. Skip means applies to say this application was none of its business. Not reached means an earlier rule declined and this one never ran. Faulted means it threw, and we will come back to that one. Recording skipped and not reached separately is worth the extra values. A gap in the record is indistinguishable from a rule that was never registered in the first place, and 6 months later, nobody can tell those two apart. The trail is also where the reasons come from. The decision letter is built from this list in the order the rules ran, rather than assembled by a second pass over the application. This is the thing the old method cannot produce at any price, and it is the honest justification for all the indirection we are about to add. Most underwriting policy has one shape. This number has to stay on this side of that number. Writing a bespoke class for each of those produces 20 near identical files. So here is one class that covers all of them. The interesting part is the constraint. It is not a base class and it is not decimal. It is INumber, the generic math interface. A credit score is an INT, a debt ratio is a decimal, a term is a long, and this one implementation compares all of them with real operators and no boxing. Try to build a threshold over a type that has no ordering, and the compiler stops you at the point of use. The priority property uses the field keyword from C#14. The validation sits with the property rather than in a constructor body, and there is still no handwritten backing field to keep in step. It is a small thing, and it is the kind of small thing that stops being small across 40 rule classes. The engine comes next. It is about 80 lines long, and it knows nothing about lending, which is not an accident of this example. It depends on the rule interface and on nothing else. Adding a rule is adding a class. There is no list inside this file for anybody to forget to update. Two things happen in the constructor, and both are about determinism. The rules are sorted once here rather than on every evaluation. Ties break on the code, which sounds fussy right up until 2 rules share a priority and the container enumerates them in a different order after a deployment. The audit trail would then differ between 2 runs over the same application, and explaining that to an auditor is not a conversation anybody wants to have. Then duplicate codes are rejected outright. 2 rules claiming the same identifier make the trail ambiguous, and the trail is the deliverable. Failing at startup is a great deal better than failing at 3 in the morning. The rules arrive as an enumerable of the interface, never as concrete types, and the collection expression turns them into an array, so the hot path is a plain indexed loop. The evaluation loop. For each rule in order, ask applies to first. If it says no, record a skip and move on without running anything. Otherwise, evaluate, time it, and write the result into the trail. A decline breaks the loop, and the rules behind it are still written into the trail as not reached. Short-circuiting is the performance story here. An application that fails the credit score floor costs 1 comparison, not 8 rules, and a policy file lookup. A referral does not break the loop, and that is a deliberate difference. A case officer wants every finding, not just the first one. If an application is referred for thin employment history and also breaches a regional cap, the person reviewing it should be told both things. Hold on to that because it is the exact behavior a test is going to find missing in the old method. One more thing inside that loop, and it becomes important in a few minutes. Evaluate is wrapped in a try. A rule that throws is recorded as faulted and turned into a referral, never into a pass. Once rules can arrive from outside this assembly, a rule that throws is code you did not write, failing in a way you did not anticipate. The one outcome that is not acceptable is silently approving a loan because a rule crashed. A human looks at it instead, and the exception type goes on the record. Here is the engine running over 4 applications. 8 rules are active. 4 are compiled classes, 3 came from a policy file, and 1 is a national ceiling. The first application passes everything, and you can read the whole path it took. Notice the second line. Prior defaults did not run at all because this applicant has a clean record and the rule declared itself inapplicable. That is a skip in the trail, not a pass, and the difference is real. The second application is referred, and it is referred for 2 separate reasons. 1 prior default and a debt ratio over the tighter self-employed ceiling. Both are on the record. The third application fails the credit score floor and the run stops there. 7 rules are marked not reached rather than left out. An auditor reading this can tell that those rules exist and did not run, which is a different statement from them not existing. Two questions are still open. How do the rules get into the engine, and how does somebody in the credit team change a limit without waiting for an engineer? The first is the container. The second is a policy file, and it needs more care than it first appears to. Wiring a rule in is one line, and that line registers it against the interface rather than against itself. The engine takes an enumerable of the interface, so the container is the composition. There is no registry class and no switch on rule identity anywhere in the system. Try add enumerable rather than add is a small but load-bearing choice. Registering the same rule twice would otherwise put two copies in the container and trip the duplicate code check at startup, which is a confusing way to learn that you called a setup method twice. The engine is registered as scoped rather than singleton, and that deserves a sentence of its own. Rules are usually stateless and registered as singletons, and a singleton engine would be fine today. It stops being fine the first time somebody adds a rule that needs a database. Resolving a scope dependency into a singleton captures the first request copy for the life of the process. That bug shows up as wrong decisions under load rather than as an exception, which makes it one of the worst kinds to go looking for. A scoped engine costs one array sort per request and cannot be got wrong. This is the policy file. 3 rules, none of them compiled. True regional loan-to-value caps and a maximum exposure limit. A member of the credit committee changes the number 75 to 70, the service picks it up, and no engineer is involved at any point. What the file deliberately cannot express is logic. There are no conditionals in it, no arithmetic, and no way to write a new kind of check. It describes thresholds, and that is all it describes. Anything more complicated than a threshold is a class, written by an engineer with a test next to it. That boundary is the whole design decision, and drawing it too generously is how configuration files turn into a programming language that nobody can debug. The other half of that boundary is which fields a policy file is allowed to talk about. Reflecting over the application type would work, and it would also let a policy file reach any property on it, including ones nobody meant to be part of a lending decision. An explicit map is a few lines longer, and it makes the answer readable. 7 figures are exposed here. Anything else fails at load with the valid names listed in the message. That last detail matters more than it sounds. The person editing the policy file is not going to read our source code to find out what they typed wrong. That covers everything a build can produce. The harder requirement is the one the business actually asked for. A new market opens, and it needs 2 rules the service has never heard of on a service that cannot be stopped. That means loading an oassembly at runtime, and it has one detail that decides whether any of it works. AssemblyLoadContext is how .NET loads oassemblies in isolation. This one is collectible, which means the whole context can be thrown away and replaced when policy changes. Isolation is what makes that safe. 2 versions of the same regional pack can be loaded side by side without their dependencies fighting each other. The load method is the detail that everything turns on. A plugin folder normally contains its own copy of the contract to assemblies because that is what building a project puts next to it. If this context loads that copy, the rule interface the plugin implements is a different type from the rule interface the host is looking for. Nothing throws. There is no error message. The type scan simply finds no rules. The whole pack is silently ignored, and you spend an afternoon on it. Returning null for the shared UHassemblies delegates to the default context, which is where the host's copy already lives. That is what makes the types line up. The project file for the pack does the same thing from the other end. The contract references are marked, so their assemblies are never copied into the output at all. The loader itself is unremarkable, which is rather the point. Enumerate the assemblies in the folder, skip the shared ones, load each in its own context, and look for public concrete types that implement the interface and have a parameterless constructor. That last requirement is the contract for a dropped-in rule. Anything needing dependencies belongs in the host container compiled in where it can be reviewed. A missing folder is not an error because the service has to start on a machine where nobody has dropped a policy pack yet. An unreadable file is not an error either. Something else sitting in that folder gets skipped loudly rather than taking the service down with it. Reloading is where it would be easy to write a race condition. Nothing here is mutated. A reload builds an entirely new engine off to one side and then swaps a single reference. An evaluation already in flight finishes against the engine it started with, which is the behavior you want. A decision is made under one version of policy, never half under each. The read is a volatile read rather than a plain field read, because without it, a thread is entitled to keep using a stale reference indefinitely after the swap. If the new set of rules fails to build and duplicate codes are the usual reason, the reload is rejected and the engine that already works keeps serving. A bad drop into a folder must not take the service down. The old context is unloaded only after the swap, never before. Unloading first would pull types out from under any evaluation still running against the old engine. The watcher is debounced because copying one assembly raises several events, and a compiler writing into that folder raises dozens. This is one process from start to finish. It starts with 8 rules and no idea that Tamil Nadu exists. The application asks for 80% loan to value that is inside the national ceiling, and it is approved. Then the assembly lands in the folder. The loader reports 2 rules found. The engine rebuilds and reports 10 rules active. Same process, same application evaluated again. The regional cap declines it 80% against the 70% limit, and the term rule below it is marked not reached. No restart, no deployment, and no rebuild of anything the host owns. The pack was compiled against the contract and copied into a folder. 3 honest caveats before anybody puts this into production. Unload is a request, not a guarantee. The managed memory comes back only when a collection runs, and nothing anywhere still holds a type from those assemblies. One cached delegate or one rule instance kept in a field pins the whole context permanently. Assume the process leaks a little on every reload, and reload rarely rather than continuously. Second, anything in that folder runs with full trust inside your process. This is not a sandbox. The folder needs the same access controls as the deployment pipeline it replaces, or you have built a very convenient way to run arbitrary code on a lending server. Third, a dropped-in rule has no review, no test run, and no version history unless you build those around it. The mechanism removes the deployment. It does not remove the need for the discipline that the deployment used to enforce. None of the design matters if the answers changed. Replacing a method that has been making lending decisions for years is only safe if you can show that it still decides the same way, and that is a testing problem rather than a design one. The engine tests do not mention lending at all. Stub rule is 3 lines because the contract is 4 members, and that is the cheapest argument for the interface there is. Short-circuiting, tie-breaking, skips, duplicate codes, and the faulting case are all covered without constructing a single loan application. The one worth reading twice is the faulting test. It asserts that a rule which throws becomes a referral and never a pass. That is the property that has to hold once rules can arrive from a folder, and it is exactly the sort of thing that is obvious in a design document and absent from the code. This is the test that makes the rewrite safe to ship. Reading the old method carefully is not evidence. Both implementations are run over the same 20,000 generated applications, and the answers are compared. The seed is fixed, so a failure is reproducible, and a pass is not luck. Parity first, deliberately, because anything the engine does differently on day one is indistinguishable from a bug the refactor introduced. Every outright approval and every outright decline matches. And then the sweep found something. 123 applications where the old method says refer and the engine says decline. That is not a bug in the engine. The old method returns a refer from the middle of the employment block. Control leaves the method there, so the regional loan to value cap below it never runs. An application referred for thin tenure went to an underwriter with no mention of the fact that it also breaches the cap and would have been declined outright if anybody had looked. Nobody decided that. It is what a return statement in the middle of a long method does, and it survived for years because there was no way to see it. The test now asserts that difference explicitly, so it is a recorded change rather than a surprise in production. 39 tests, and they finish in about half a second. That number matters more than it looks. A test suite that runs in half a second gets run on every save. A suite that takes 4 minutes gets run before a release, which means the feedback arrives long after the decision it should have informed. Here are the numbers measured with BenchmarkDotNet on a laptop, and the laptop part is worth saying out loud because the variance on these runs was high enough that the tool warned about it. On the approving path, the old method takes about 150 nanoseconds and allocates nothing. The engine takes about 1,800 nanoseconds and allocates 744 bytes. That is roughly 12 times slower. 12 times sounds alarming until you write it in the units the system actually runs in. 1,800 nanoseconds is 1.8 microseconds. A single database round trip to fetch the applicant's credit file is on the order of a millisecond, which is 1,000 microseconds. The entire rule engine audit trail included is about 0.2% of one round trip. On the declining path, the ratio is worse and the absolute numbers are smaller because the old method short circuits to almost nothing. Part of that cost is a deliberate choice you can undo. The engine takes a timestamp around every rule, so the trail carries up a rule duration. And if you do not need that, it comes out and the number drops. The point of running a benchmark is not to win it. It is to be able to say what the abstraction costs when somebody senior asks with a number rather than a shrug. When not to do this, because that question has a real answer. If your rules genuinely never change, this is overhead with no return. A validation routine for a file format is not a rule engine, it is a method. If you have 3 rules and they have been the same 3 rules for 4 years, leave them as if statements and spend the effort somewhere it pays. The pattern earns its cost when 3 things are true together. The rules change on a different schedule from the code. Somebody outside engineering has an opinion about them. And you have to be able to explain a decision after the fact. Lending, insurance, pricing, entitlement, compliance. If none of those describe your problem, then the indirection is real and the benefit is not. The other honest cost is the stack trace. When something goes wrong inside a rule, the trace runs through a virtual call from a loop in a generic class, and it is a good deal less pleasant to read than a line number in a method. The audit trail makes up for that, but only because we built the audit trail. The shape worth taking away is smaller than the video. One interface with 4 members. An engine that owns the order and the record and knows nothing about the domain. Rules as classes, thresholds as data, and a folder for the things that cannot wait for a deployment. Everything shown here is in the repository. It builds on .NET 10, and the tests run in under a second. If you want the next one to cover rule dependencies where one rule needs the result of another, or the version where rules call out to a credit bureau and have to be asynchronous, say which one in the comments.